Hello, everyone, and thank you very much for joining this session, and thank you, David, for hosting it. I'm glad to have this opportunity to discuss smart metering and smart grid topics with you. My name is Camille Marzuoli, and I'm a managing director at SIA Partners in Paris within the energy and utility practice of the firm. And I've been working in this field for almost 10 years, and more than half of it within the smart grids topics overall. Obviously, I'm French, so in advance, I apologize for my accent. In today's presentation, as Kim said, we're going to go through, first of all, a quick landscape overview of smart meters deployments in Europe. Then I'll talk about different important lessons that we learned after over 12, 15 years supporting smart metering projects. And finally, I'll give you a few examples of how smart meters can be leveraged for smart grid purposes. So first of all, our landscape overview of France and Europe. I'll start maybe with a quick reminder in case not all of you are familiar with smart meters. So what are smart meters? They are meters for electricity, gas, or water that can communicate remotely with the systems of the utility with no human intervention. So the smart meter in itself measures obviously energy consumption at a client's premises, and it's part of a larger smart metering infrastructure that comprises the meters, but also some telecommunication equipments in the field like DCU, data concentrator units, and obviously a lot of IT systems to make the whole thing work. In the electricity sector, smart meters usually include a circuit breaker, and they allow the utility to do a lot of different things. The first one being obviously to collect the consumption data daily for all the clients. They allow to collect more detailed load curve of clients, and they allow to do a lot of operations remotely, including power activation, power cutoff, to manage different tariff structures, and to manage contractual changes remotely. They can also push alarms and act as sensors on the grid to give utilities some observability over the grid and detect some defaults or some problems. So the development of smart metering in France and in Europe has been globally driven initially by different factors, but the most important one was European regulation. The European regulation in Europe imposed on every European country to analyze the opportunity for smart meter deployment and to aim for 80% of deployment in 2020 if the business case was positive. Obviously, some other factors have come into play. The technology to do this at a large scale is now available at an acceptable price. European consumers now, I would say, have a lot more expectations towards energy suppliers. And of course, the energy grids are transforming quickly, notably because of the integration of renewables and the integration of electric vehicles. And as a whole, this makes the monitoring and the supervision of energy grid much more important now than it was before. Overall, I would say smart meters bring a lot of benefits to the entire energy ecosystem. And I won't go into details over every element of this slide, but what is very important for me to understand is that smart metering is an enabler. It's not an end in itself, it's a tool. It's a tool that brings value to all the stakeholders in the value chain, and they bring value to obviously the grid operator, but also the suppliers, also the clients, and obviously the local authorities too that can have a better view on energy usage in their territory. So where are we in Europe? To this day, we have around 120 million meters installed, smart meters. That represents around a little less than half of energy meters on the continent. So we're falling just a bit short of the 80% mark for 2020, but we have a lot of countries that will reach this target of full rollout by 2020. That includes France, although maybe we lost a few weeks because of the coronavirus situation that you're all aware of, but we will reach the mark of 80% by 2020. And many more countries are proceeding with rollouts or will be soon. So we will reach the target of 80%, just not in 2020, a few years later. If we take a look maybe at some very significant major deployments, we can mention obviously Italy with Enel, and they were the first in Europe, and they deployed over 30 million meters in 2002, 2005. And actually, they're now launching their second generation rollout, as their first generation meters are now reaching almost 20 years old. In Spain, we have Iberdrola and Endesa. They deployed over 20 million meters. And for example, we have a smaller countries like Sweden with Vattenfall and E.ON that rolled out around 5 million meters, and they too are getting ready for a second generation. There are a lot of smart meters projects that have taken place in the US, as you are well aware, of course. And in Canada too, we have, for example, Hydro-Québec in Quebec that has rolled out over 98% of its clients for almost 4 million meters. And I stress it because in Canada, we work for Hydro-Québec too. One point maybe that is worth mentioning is that we can see a difference of approach in terms of technology between what we see in Europe and what we see in North America. In Europe, the utilities have vastly opted for PLC communication. So they use PLC to make the meters communicate. They use the power line to reach the systems of the utility through a data concentrator unit on the grid. Whereas in North America, the more standard technology used is radio technology. This difference is due to different factors, notably population density, which is higher in Europe and makes PLC more relevant, but also I would say some industrial standards that have come into play and some industrial preferences. Maybe a short focus on France to end this overview. At SIA Partners, we've been supporting distribution network operators throughout their smart metering deployments for over 12 years now. And obviously, being a French firm, we started with France. We've had two different smart meter deployments in France, one by the electricity DSO, Enedis, and one by the gas DSO, GRDF. If I focus maybe a bit more on the electricity side, we can see Enedis started with a pilot project of about 300,000 meters. They were dispatched in two distinct areas, one urban and one rural. And the goal was to experience, I would say, and to prove the system over different network configurations. Then from 2016, the full rollout of 35 million meters began. And the time in between the pilot and the full rollout was used mainly for experiencing the system, of course, but also to improve its performance, because at that time, smart metering system and technology was not as mature as it is today. And after the pilot, the performance was not so good, and we had to work, I would say, very, very hard for a long time with alongside Enedis to make the whole system work and reach the target KPIs before we could get a starting point for generalization. Maybe to introduce the second part, we can pinpoint three main challenges that we'd like to highlight for distribution network operators that are launching smart metering projects. And from our experience, that would be, first of all, public relations, to convince public opinion and to communicate well to them. Meeting performance expectations, as I said, is also a very key factor to the success of the project. And finally, change management, because As a utility, pretty much all of your business processes will be impacted, and some of them to a great extent. So I've come to the end of the first part, and I will take some questions if you have some.
Are there any questions? I don't see any in the chat. I don't know if David or you, Camille, received any, but are there any questions from the group? While waiting, Camille, maybe you can talk a little bit about the implementation across the different European geographies or even between entities and GDRF. What were some of those differences?
Yes, of course. In France and in Europe more globally, as you know, we have an open market, and the European rules have imposed onto us to separate the supplier's activity from the network and distribution network activities. So suppliers in Europe, the one with which clients have a contract for energy, cannot be grid operators too. The grid operators have to work for all suppliers in a fair manner. So in Europe, it is grid operators, obviously, who are responsible for the deployment of smart meters. And in some countries, like France, we don't have the same network operator for gas and for electricity. So they basically launched two very separate and different projects. In France, actually, those projects were launched approximately at the same time as those activities were getting separated, because before gas and electricity were all together in the same firm. And as those activities were getting separated, obviously, it really would not have worked well to make a joint project for gas and electricity at the same time with two companies separating.
Great, thanks, Camille. And we do have a few questions. Thanks to everyone for submitting. So how did the data privacy laws impact the use of AMI?
That's a good question. Thank you very much.
Specifically in the countries. Yeah, go ahead.
Yeah. In Europe, different countries, I would say, have different levels of sensibility to this question. So each country has addressed it in its own manner. For example, you may have noticed that in Germany, we don't have any full smart meter rollout. And one of the reasons for that is the very high sensibility of data privacy in the German public opinion. And they have actually a regulation which is very strict about energy and data privacy. And when smart meters were getting ready I would say in 2005, 2006, the regulation was too strict, and the systems were not ready yet to support the level of data privacy that the regulation imposed. And that's why that's one of the reasons, at least, why Germany chose not to go for a full rollout at that time. In France, the situation is different. We too have a strong data privacy laws. And to address them, I would say Enedis, the electricity utility, has worked very closely with the regulator for data privacy in France. And they are auditing the project very closely all the time. And Enedis has to is held accountable at all time for the use of the data, which remains the property of the clients, obviously.
Okay, great. Thanks. And then one other question, and we'll move to the next section. Are there any functional limitations to what services you can offer using PLC AMI in Europe compared to the RF AMI in Quebec?
The two technologies bring both some advantages and some inconvenience, I would say. If we look at PLC, the great advantage of PLC, as seen by European utilities, is that it makes the communication network the same as the electricity distribution network. And that makes a few use cases possible that are not possible with radio frequency. For example, that can really help utilities to master their knowledge of their grid in terms of who's connected to what transformer. And this is not really possible with RF. On the other side, one of the problems with PLC is that when there's no power, there's no communication possible. Whereas with radio meters, if you have a small battery in the meter, it can still work and function and communicate even though the network is not providing power. So for some use cases like outage management, radio can bring some advantages, yes.
Great, thank you. Lessons learned. Thanks, Camille.
Okay, thank you, Kimberly. So in this second part, we'll go further into a couple lessons we learned related to the 3 challenges that I mentioned in the last part. And the first one was about public relation. Smart meters rollouts are obviously sensitive project because you have to disturb every single one of your clients. You have to get into their homes. You have to change their energy meter. As I said earlier, in France, we had 2 different smart meter rollouts, one for electricity and one for gas. And they kind of chose 2 very different and opposite communication strategies. The first rollout to start was the electricity one. And actually, Enedis chose what I would call a strategy of visibility. So they gave the meter a flashy green color. You can't see it maybe so well in this slide, but it's really flashy actually. The green color was supposed to represent the energy transition. They gave the project and the meter a name, Linky, and the name is written on the meter. And they made a lot of public communication about the projects, a lot of press campaigns, posting about the benefits for the consumer and the benefits for the electricity sector as a whole. This strategy did actually not work so well because and it's kind of over communicated and their communication was a bit too rational, too technical, and that isn't necessarily well perceived by the public. You have to address irrational factors too, which Enedis didn't do, at least in the beginning. And as a result, they faced quite, I would say, a loud opposition to their project, which stemmed from a very small minority of clients and of political representatives. It didn't slow the project at all, but it made a lot of bad buzz. And in terms of images, that was not what they expected. On the opposite side, so you have GRDF and their gas metro rollout. They had the good fortune to come second, so they had time to see what was going on with Enedis, and therefore just chose quite a different strategy. They did not make any big public communications or press campaign. They tried to go below the radar in terms of public opinion. And at the same time, they worked really hard and really well with all the important third parties that they had to convince with many key opinion leaders. They worked with the regulator, obviously. They worked with local representatives. They worked with customer associations to include them in the project from the start, to address their fears and to take into account their recommendations too. And as a result, I would say they faced much less opposition from the public, and the image of the project is better, and it's also much less known. Actually, people in France all know about the Linky project for electricity, but most of them don't really know about the gas metro rollout because there was not so much communication. The second challenge that I want to talk about was end-to-end performance. So the smart metering market now, it has become much more mature than it was 10 years ago. But overall, smart metering infrastructures are still not plug and play at all. And in order to deliver benefits, of course, they have to work well, and to that extent, end-to-end testing is absolutely essential. This relies on different expertise areas that are not always well developed within utilities and distribution network operators. I'm talking about telecommunication expertise, data processing expertise, and also cybersecurity. So the fine-tuning of performance is quite effort-consuming, and it has to be anticipated a lot because it completely drives the benefits of the project, of course. In our experience, during the first stages of the project, actually all the project's energy is focused on securing field operations for deployment and fine-tuning the system's performance. And only when this is done, and when I would say the tool is working well, then only utilities can start to put more energy into leveraging the infrastructure, into developing smart use cases. But really the first step is to reach the target performance, and all the rest depends on it. There are a few strategic choices that will help secure this end-to-end performance and to ensure the maintainability of the system for a long period of time. First, we really recommend to all our clients in the framing of their project to opt for standards, especially regarding communication technology. Whether we're talking about PLC, radio, or cellular, there are standards that have emerged, and opting for one is a guarantee for long-term support. It's a guarantee that people will be working to improve it over time. The second point is to ensure effective interoperability by sourcing the meters and the DCUs or the gateways from at least 2 different manufacturers. And that's actually the only way for us to actually prove interoperability really in an effective way from the start. And that will help over time to really drastically reduce your dependence to any single manufacturer and to ensure that your system is interoperable between different metro vendors. The last challenge that I mentioned earlier was change management. So smart metering obviously is a very transformative project for an electricity or gas utility. All business processes are impacted in some way, and the project must include a very strong HR transformation layer. If we take a look at the existing activities, then obviously some will be automated, in particular meter reading, of course, but also a lot of small contractual customer intervention, like contractual power change or power cutoff, power turn on. All of these activities can be done remotely. So that requires to anticipate the HR transformation and the HR impact. The different types of data that is collected by the smart meters also have the potential to transfer maintenance through predictive maintenance, for example, and to transfer grid management. And we'll see a few examples of that in the third part of the presentation. In our experience, I would say support functions are also very heavily solicited during the transition, whether it be finance or HR. The project is so transformative that it puts quite a strain on them. Moreover, I would say we were talking right now about existing activities transformation, but smart meters also imply the creation of new activities within utilities. First of all, of course, there's the management of the rollout in itself. That's a new activity, and that usually lasts at least a few years. And the integration of the new metering infrastructure within the legacy IT is another activity. But in addition to their core business of grid management, smart meters imply that DSOs have to manage their own telecom network, and that's a new business usually for utility. Also, the massive amounts of data that is generated will make any utility become a data operator as well. So overall, this means that utilities that launch smart meters rollout have to mobilize new skills related to telecommunication, to cybersecurity, and to data science. Okay, so end of part 2. Any questions?
I'll take a question. While someone might be talking, one quick question, Camille. For
Yes.
those lessons learned, what was the most significant impact to the implementations? Was it in, timing, cost, delays, public perception? What were some of the most significant impacts of learning those difficult lessons, if you will?
Well, it's hard to pick one in
Yeah.
particular, but
Or
um,
memorable?
yeah, I would say um, securing performance from the start. Maybe it's not the most fancy one, but that's a very important one because the whole output of the project relies on this. I mean, you can go through a bad buzz campaign of communication. In the long run, the project will still be able to be rolled out, and the benefits for the utility and for the system will be there. If the performance is not there, then nothing can work afterwards. So securing performance, uh, both by opting for standards, by anticipating the skill acquisition to do the end-to-end testing, to secure the skill sets that you need for managing the system in the long run. This is to me maybe the most important one. Yes.
Camille, this is David.
Yeah.
You mentioned earlier in your presentation that a number of these utilities are preparing for round 2 or rollout number 2.
Yeah.
Can you cite any specifics as to what they learned on round 1 and how they changed around the round 2 rollout?
There's I would say 3 different areas with this. The first one is regulations. Some of the regulations have evolved in these countries, and I think for Italy, for example, the new regulation for performance of the system, for data privacy, makes the old system, the old measures maybe obsolete. So they have to comply with new regulation with new systems and with new specifications for the meters. The second part, I would say, is that um, especially for the most ancient rollout, the focus of this project at that time was more on the client side, so remote reading of energy consumption, remote activation, deactivation, and so on. But sometimes the grid management functionalities had not been sufficiently anticipated and sufficiently specified when they bought the system and they acquired the smart meters. So now they have much more, I would say, background. They have much more experience, and they know what they want from their systems more. They know better what they expect from their system, and so that allows them to prepare a better specification that is more tailored for their own needs.
Really excellent. Thank you.
Yeah.
So leveraging smart meters. Thank you.
Okay, thank you very much, Kim. So in this last part, we want to give you a few examples of the way that smart meters can be leveraged for smart grid purposes. So obviously, the primary function of smart meter is to read consumption, but they also increase, I would say, the level of observability that we have over the grid, and that enables a lot of different possibilities. And I'm going to show three examples of smart use cases that we at SIA Partners played a key role in implementing within our clients. So the first one I want to talk about is outage management. With smart meters, TSOs have a tool that can help them detect and localize faults and outages more easily in near real time. That can't work for all outages and all faults, obviously, but for most of them, the smart metering infrastructure can help. So here is an example of something we implemented with Enedis, the French electricity utility. If we look on the medium voltage grid side, usually faults are detected in near real time by the dispatching centers, so they don't need smart meters to detect faults. But the challenge for them is to find their location quickly enough to activate the right circuit breakers and to restore power supply for most clients as quick as possible. So on the MV side, the challenge is localization of faults and not so much detection. So what we did on the MV grid is that we used the DCUs, the data concentrators, as voltage sensors in the MV-LV transformer stations to better locate faults like cable breakages, for example, much more precisely and in a matter of minutes. Some of these faults could literally take hours to locate before, and now when these kinds of faults occur, then the DCUs that are downstream of the fault will record a specific pattern that the DCUs upstream of the fault will not see. And that way, we can locate the fault much more quicker than before. On the LV grid side, the low voltage grid, the challenge is more to, I would say, detect outages quicker than before and to start acting on them before client calls, because before smart meters on the LV side, for most utilities, we are blind, we don't see anything, and we have to wait for client to call to know that there's an outage. So to do this, we can use DCUs too, and we can also use the smart meters themselves by implementing the right type of alarms and by interpreting also and comparing the alarms and the data that's coming in real time for the meters to what we know that's happening on the grid at this particular moment. And to that extent, it helps us with Enedis to detect outages much quicker. And in a lot of cases now, Enedis can actually start to send their guys on the field even before clients have called. The second use case we'd like to show you is predictive maintenance. So outage management, is about using smart meters data in real time or almost real time. But smart meters, they also obviously collect data that can be used later, and they act as voltage sensors on the grid. And the data that they collect can be processed to identify fragilities on the grid. So with Enedis in France, we have launched a project that uses machine learning algorithms to identify signals of future faults in the LV grid. And with the voltage data we gather, we can detect signals that something is about to break. So that helps Enedis to be more efficient with their grid management and to prevent some future incidents and future outages by intervening before the actual breakage occurs. The performance of these algorithms is quite high, actually. And within this, when the algorithm that we help put into place recommend an intervention, we observe that if we don't intervene, 90% of the time we will have a breakage or a client calling for voltage problems in a few weeks. Okay, finally, to end this presentation, last use case about smart grid capabilities for fraud detection. In this example, we have a system that we developed with Enexis, which is a Dutch utility, Dutch electricity utility. And they had a problem with illegal marijuana farms where people were connecting directly to the grid and stealing a lot of power. So they had their MV-LV transformer stations equipped with smart meters. And we used this data to detect abnormal consumption patterns, which led to hundreds of frauds detected every year. So that's only an example, obviously, and there are several different ways that we can use smart meters to detect fraud. And we feel like to get the best result, you have to combine those different methods. We actually at SIA Partners have a data science center, which is called HECA. You have the link on this page, and if you click on it, you will be able to check our different demonstrators of those kind of capabilities by using smart meters data. So that's it for the presentation. I'll be very happy to discuss any questions you may have. Thank you for your attention.
Any key, lessons or things for us here in the US that we can take away from European implementation of smart meters?
That's a tough one. I would say maybe when I talk with Canadian or North American actors about smart meters, I would say the different telecommunication technology that can be used are not always well known. In Europe, many actors don't really know much about radio, and in the US, many actors are not very familiar with PLC, for example. So I think it's really enriching to get to know more about the very different communication technology that can be used and how they have an impact on the use cases that are possible, so that when you frame your project, you really make the right choice with the right technologies.
Okay, great. We do have one question. Can you elaborate more on leveraging smart meters in the predictive maintenance space?
Okay, so if I come back to that slide. So if I maybe I can tell you a bit about the history of this small project. With Enedis, we started a few years ago working on outage management, actually, through smart meters. And to do this, one of the levers that we used, one of the possibility was to leverage the alarms that smart meters could push when they felt an over voltage. And we thought at that time that over voltage on the grid, as detected by smart meters, was a significance necessarily of a neutral cable breakage. That's what we thought. So basically, when we had this type of alarms, we would push it to the grid management people and saying, so we know that you have a neutral cable breakage somewhere. You have to act on it. It didn't take us more than a few weeks to understand that about 95 or 99% of those alarms were not related actually to a real neutral cable breakage, but most of them were the signal of something else that was maybe about to happen, of some transitive state, of some thing that was coming and going. It was not a frank incident at the time, but it meant there was a fragility somewhere on the grid. So that meant, first of all, that we had to filter the alarms that we sent to grid management people to be really sure that something was actually broken before we send them on the field, of course. And that meant also that we had the material, the data, to study, to maybe find some fragilities, to intervene now, to prevent future breakages. So to do this, we actually built a user interface that you can see on the screen on the right. That was meant to represent the network and to represent the history of the network in terms of voltage behavior. And we put this in the hand of a maintenance expert and grid management expert within Enedis. And we asked them to qualify the events, to tell us what was significant, what was not, what was critical, what was not. And we used machine learning algorithms to be able to predict just as well as the expert would have on any future pattern of voltage. And that's what we did. And now we have enough qualification of events, enough data with human expertise layer on it to be able to reproduce this human expertise through machine learning, and to be able to say through these algorithms whether one should intervene on the network because something is about to happen, or if it's just something that's not critical at all.
Great, thank you, Camille. Okay, and then another question. Thank you, Shane. So you mentioned that Europe was at 50% rollout versus 75% target. Can you share what some of the main issues are that are causing the delays in the rollout, beyond COVID? Is there a timeline for the completion? I know you mentioned 2030 for the remaining countries.
Yes, so if I go back to that slide, so in I think it was 2003 or 2004, something like this, Europe imposed on all countries to do a business case to see if deploying 80% by 2020 was a positive business case for them. And for all of those countries who said yes, they had to reach this target. That was the plan. So some of the countries chose to go for it, like France, Italy, Spain. Some of the countries took more time to assess, I would say, the business case. And some countries assessed a negative business case, like Germany, for example. And so they did not start the rollout. So some countries will probably not, in the short run, go for 80% rollout at all. And some other countries, like, I don't know, maybe Belgium, are a bit late on the target because sometimes they have more complex landscape. In France, we have one very, very big utility, Enedis, which is managing 95% of the grid. But in some other countries, there are many different utilities. And the fragmentation of the grid, I would say, is a factor that can slow down the project, because either the different grid managers in the country will go for completely separate projects, which is not a very good solution because it's not interoperable, or they have to think together and to act together to build a common specification and a common project, and this takes a lot of time sometimes.
Great, thanks, Camille.
Thank you very much.